Okay, then. Let's see. So now we're asked to find the moment about B of the force applied at point A. So let's see what we have. Let's draw an FBD. That's always a physics teacher's favorite thing to see. So let's make all of the physics teachers and professors in the world happy. Let's see. Tension. Let's see. AB is held in place by tension. AC. Tension in the cord here. It's gonna look like this. We're gonna call this TAC. And we know that TAC is equal to 1350. And that this distance here, C equals 360 millimeters. Splendid. Wonderful. So, we're going to find this through moments, right? So now we have a force and we have a point. Now it's asking us to take it a moment about B. So here's what we're taking it about right here. So we're going to have a force. Looks like it's going to be applied on B from A. And TAC is going to have a Y component and an X component. This is going to be f of Y. This is going to be f of X. And that's going to be applied at B from this distance and from this distance, R cross F, whatever happens to be perpendicular. So let's find f of X and let's find f of Y. I don't think I need those. I think I can just say they equal. This is going to be TAC, and this is why we're given. This is why we're given the height of C and all that, because we're gonna need to find the angle. So we're gonna have cosine of an angle, and we're gonna have TAC sine of an angle. Now we're gonna have an angle here of, I'm gonna call it phi, and an angle here of theta. Now we also have this, which is 90 degrees, so we might be able to just use that to find this angle and then put our middle fingers up and say, screw you, trigonometry, you don't get me. No, but we have to anyway. We don't have enough information without it. Looks like we need to do our trig anyway, but we might be able to do similar triangles or something like that, or maybe we just find that angle with the hypotenuse and use that as the base. Right triangle trig. Nah, we can probably just subtract the two inner angles once we get this outer one. So let's see. Theta equals tan inverse of opposite over adjacent which is 28.07, and then phi is going to be equal to tan inverse of opposite, which is 240 plus C, so it's going to be 240 plus 360 over its base, which is 450 still. So that is going to be equal to, let's see, 240 plus 360 over 450. This is going to equal 53.13 minus 28.07, which equals 25.05. Boom. So now we have our two angles. Looks like we have to combine those two. So the real angle is going to be phi, or theta plus phi, because we want this angle here. This will give us direct x and pure y, so it's going to be $28 plus 25. It's 53.13. I could have had that the whole time. I'm so stupid. But you know, sometimes people are stupid and you gotta live with it. So to all those smart people out here cringing at me, you know, deal with it. Wait a second. Yeah, if you're smarter than me, why are you watching this? Only people that can't figure this out are watching this. I'm the smartest guy in the room. Oh boy, this never happens to me. What do I do with all this power? Alright, I should focus on the problem. 53.13. 53.13. So now I'm getting 1350 cosine of this angle. That's giving me 810. And then sine of that angle, I'm getting 1080. Those are my forces in the x and y. So now let's take the moment about B. So our distance r is going to be 450 times Fy, which is 1080. And that's going to rotate this thing clockwise. This is going to be negative. And then x is going to be counterclockwise. That's going to be plus 240 times 810. And this whole thing, let's see what this equals. This is going to be fun. I'm getting negative 1053. Oh, 105300. Let's see. Oh, something's wrong. Something's always wrong. The moment about B, the force applied at point A. Clockwise negative, counterclockwise 240 times 8. Oh, I have 810 and 1080 mixed up. My bad, my bad. Okay. Now I'm getting negative 291,600. Oh! Something's wrong. Something's really wrong. They want this in Newton meters, and everything's in millimeter. So let's do, what, 1.08 and then insert 0.810. 1.08. Is it going to be negative 291.6? Okay, yeah, it's gonna be positive 291.6. I don't think you can have a negative force, and that's the only reason why. So 291.6 Newton meters.